Hi, it's Jerry with ilovervlife. There are many of us who need to power 120 volt appliances or devices off of our battery supplies, regardless of whether we have an RV or we're out camping, or even more importantly, we need it for disaster recovery efforts. And today I want to be able to show you this BougeRV, very economically priced 2000 watt inverter, very feature rich. I think you want to stay tuned to this video to see how it can be used. Hi, it's Jerry. One of the things that we've been doing this year in our RV travels and looking at evaluations are devices that we can use to power 120 volt appliances or tools while we're out and about in our RV or while we're out camping. I think that's very important. And I think it's even more so important. This is being recorded in October of 2024 as we're looking at just substantial, heartbreaking weather disasters that are going on, and what can we do for disaster planning. Briefly, just to talk about if you're using this for disaster planning, it's kind of like a day late and a dollar short if you're buying it now. You needed it weeks ago. So if you're doing any type of disaster planning, this is something I would suggest that you put in your what I call your home kit or your RV kit, and you start making these investments early and be prepared when that time comes about. And one of those is having a battery and having some type of an inverter and a solar panel. And that inverter is that critical device that allows you to convert 12 volt battery into 120 volts AC so you can power devices. Now, we have been working with BougeRV for a couple years since we started our travels and looking at a number of their devices. Contacted them recently and said, I'd like a mid-price inverter that I can show on the channel for people who want to be able to do something like a van build or a bus build, or if you've got a mid-size camper, something in that range. A 2000 watt I thought was that sweet spot that you could use, but something that was not terribly expensive, but yet it was feature rich. And or you could use it again in your home if you needed to have something for disaster planning. So I'll kind of show you that setup here as we go forward. This is what they sent me. This is the BV122000, BV122000 2000 watt inverter. Now this is a pure sine wave inverter. And why is a pure sine wave inverter important? There's a lot of things that will not work with what they call a square wave. Now, one of the things that I'll show you as we do our testing is we'll put something called an oscilloscope, and a sine wave is just like this. Think of it as an inverted S. It'll be a perfect inverted S, where that is what it looks like when power comes into your home or you're hooked up to a camper pedestal and you're getting power in. That is sine wave power that's used to power devices. And the reason that's very important, things that are very sensitive like TVs, computers, a lot of your electronic devices do not like something called modified sine wave, which is, if you were to look at it, it would be a square wave. Instead of being the S that comes up, it goes square, comes back down. And those devices, a lot of times, even some of your appliances will badly misbehave on a square wave. So you always want to try to find an inverter that is sine wave. And this again is the BougeRV BV122000. This is a very nice unit. It's very feature rich. It is 2000 watts. Now you can power a lot of things on 2000 watts. Roughly that is about 15 amps, 15 to 20 amps depending on the configuration. To show you the back side of this one, we have two plugs here. These are rated at 15 amps, so you can get a lot of power out of something like this. But equally important is if you look at this, it has a hardwire option. So you can actually wire this into a plug that you would plug into inside of your RV or have it set up in your home depending on what your configuration would be. The nice thing about this gives you an additional 5 amps. You can get the total 2,000 watts out of this for a 20 amp hardwire connection, so that's very, very important. And again, these plugs are 15 amps. Still, you can power a lot of devices off of 15 amps. The other thing about this unit too as well, not only is it 2,000 watts, but it has a 4,000 watt peak. So things like residential refrigerators, when the compressor kicks on, you have a bit of a surge. Now, I doubt you're going to find too many refrigerators that are going to require 2,000 watts. But what will happen is you might have the refrigerator going. You may be watching a TV. You may have some computers being charged up. Any of those types of things. Then all of a sudden the refrigerator comes on. You're well within your 2,000 watt budget operating power, but then you have that compressor surge for a second and then the inverter shuts off. Well, with 4,000 watts, it gives you plenty of room to be able to do what they call inductive devices. That would be things with a compressor, something like a skill saw or an air compressor. We're going to test all that as well and see how it performs. So this is a 60 hertz unit. So if you're in the United States, the 50 states, this will work fine in those areas in North America. And if you're needing this somewhere else, Europe, where you don't have 60 hertz, this will operate as 50 hertz as well. So you can option it for either one of those. I like the operating voltage. It'll work well if you're going to use this within a lithium battery. So that's what we'll be testing with, is a lithium battery. And that lithium battery that you can operate in ranges of, say, down to about 10.5 volts, usually in a lithium, and then up to about 14.4 to 14.6 during charging periods. That's very important. So this will work well within that range. It's rated to work between 10 volts and 15.5 volts. So you're kind of in that sweet spot of where lithium batteries work. Now you can use this on lead acid as well. You're just not going to get as much operating time out of a lead acid battery as you can lithium. You can look at plenty of our videos that we've discussed lithium batteries in the past. Now, something else that we've got to think about is load efficiency, and I'll go about talking about that a little bit more in depth. Its average is 90% load efficiency, but on a full load, and that's what I like to calculate on, is 86%, and I'll show you how that comes into play here in just a minute. And again, I talked about the outlets that are very, very important. Let me show you a couple pieces here. So aside from this unit, it's not very, very heavy. It's got plenty of mounting positions that you can mount it in various locations. I would suggest either mounting it as such, like this. You've got your big terminals for your batteries here. You could mount it horizontally as well if you needed to be able to do that. Just make sure you've got plenty of airflow, because this is going to generate a lot of heat. So this is the unit itself. It also comes with a control cable and a control panel that you can use. It has another feature that I'm going to be testing as well. So you can mount this somewhere within your camper or within your home or on your disaster recovery board, so that you can monitor the performance of that. It comes with a very, very long cable. I don't know how long it is, but it's very, very long. Should be able to route it from most locations where you have this, and be able to route it into an area where you can look at it with no problem. Now, it does come with 2 small cables. I don't know what the size of these cables are. They're pretty small, but I would say if you're going to get into the 15 to 20 amps, I would not use these. I would go with something like a 2-aught to a 3-aught cable, depending on the length. There are amperage charts that you can use to determine what the length of battery to inverter should be. There's plenty of them out there. There's dozens of them to calculate your wire size. But I would say to go ahead and plan for something like a 2-aught or a 3-aught cable for something like this. And then they give you 2 bags of fuses. That's very nice. Typically they don't see that. And then the last thing they provide is a jumper wire. So a lot of devices cannot have what they call an open neutral. So you may have to strap the ground to neutral to be able to cause certain devices not to alert or fail because they're looking at what they call an open neutral. So just in case you need that, they have that available as well. So it's a very, very nice unit. Now, two other things that I want to cover here quickly about using an inverter and using this inverter specifically is there are those who want their inverter to where instead of switching it off and on manually, or you have, let's say, an AC outlet, it becomes very, very important if you're going to hardwire this in, or even if you're using the plug-in as well, to where you want to be able to switch from inverter to what I call shore power. Let's say you're using this at home in a disaster recovery perspective. You got your refrigerators and your freezers hooked up to it. You lose power, you want the inverter to be able to be utilized and pull battery power during that period of time. When power comes back on, then you want the inverter not to be utilized any longer. And we see that so often in your campers, your RVs, your bus builds, your van builds. I have the same configuration here using a different style of product. But if I'm into shore power, I'm not pulling from my inverter. If I disconnect from shore power, then my refrigerator and etc. will pull from the battery. This device, at this price point that they're offering, does not have a built-in transfer switch, and that's not a big deal. When you're starting to look at those units, they can be $500, $600, $700, $800, up to $1,000. This unit right now, looking at the website at BougeRV, is $289. That's right, a very feature-rich, full sine wave, 2,000 watt with 4,000 watt surge protection for $289. That's really a great value. So if you do want to be able to have that capability, and this is what we're going to be using in our application, we are going to put in our own transfer switch. This is a 15 amp transfer switch. We're going to be using this in my daughter's build in a future video to where we are going to be powering a refrigerator, and that refrigerator needs to be able to run off of pedestal power when they're hooked up to a campground, or they need to be able to run off the battery when they are not hooked up to that. So we're going to use this. Now this is not a very expensive unit. These things are great. They come pre-wired. You just, the guide is very, very simple on how to use those. And again, I'll be showing that. And this is not a BougeRV product. This one is by HCDC. I will provide a link in the description at ilovervlife.com in today's blog. I'll also provide it in the description that we have in the YouTube video as well. If you're looking for something like this, they're very inexpensive, they're very reliable. This unit is specifically very, very reliable. And what will happen is you plug in, this switches, you're no longer pulling from the inverter, you unplug from pedestal power, and then you start using the inverter again. And I'll turn the inverter on and I leave it on, I never turn it off. It just continuously is available, and it has a very, very low trickle, I think less than 3%, that it's consuming of your battery during that period of time. Now here, that's the first thing that I want to cover. The second thing I want to cover is how many amps are you going to need in a battery to be able to meet your AC needs. This is a huge discussion. If you're on any of the Facebook groups where we talk about inverter power or power station power, those types of things, it is the daily question for multiple people who are looking for calculating something like this. I will mention this to you. If you need 10 amps coming out of your inverter, you're not going to be using 10 amps out of your battery. There is a conversion factor that is quite substantial. Now, I like to use, I'm an engineer by trade. I was an engineer for a long time, and I dealt with large telecommunication power plants and things like that. And when you're doing quick calculations, we call them back of the napkin. So the back of the napkin for something like this, I'm going to use something that's very, very common to all of us. If you look at that thing right there, that's a microwave that comes up so many times. I have this microwave, and I want to be able to use it on my inverter. How much power or how much battery do I need? Well, first of all, if you're going to run something like a microwave that is residential style, you're going to need a 2,000 watt inverter. Just go ahead and share that. Now, if you're going to use one of these Walmart little white teeny specials, usually those things will run 800, 900 watts. Those big boys like that require 1,800 watts of power coming into it, usually to generate 1,000 to 1,100 watts of cooking power. Big conversion factor. I'm sorry, getting into the technical weeds, but there's conversion factors. Think about that, 1800 watts. So let's use that in the back of the napkin. If you just want to just kind of quickly come up with something that says, okay, how much battery capacity do I need to be able to run this thing here for 10 minutes? Then how many amps do I need coming into it from a battery? So the back of the napkin is divide by 10. That's the quickie. That's the quickie to be able to do that. So what would that be? 1800 watts divided by 10 is 180 amps. That's kind of a back of the napkin. Now, if we want to look at the technical formula right here, then it's going to be something a little different. It would be 1800 watts divided by, I'm going to use the lowest voltage. Now you may be starting off at a voltage of say 13.6 out of your lithium battery. It may go down to 13 volts, it may go down lower, but you're going to get down at some point to about 12 volts. Now in electrical calculations, the lower the voltage, the higher the amperage draw. So as that battery gets weaker, we're going to actually generate more amps, just the way it works. So here's the math. 1800 watts divided by 12 divided by, remember I was talking about that full load efficiency rating of 86%? So that would be 0.86. 1800 watts divided by 12 volts divided by 0.86. Guess what you come up with? You're right, 174 amps. See how quick I did that? So again, going back to that back of the napkin, 1800 watts divided by 10, 180. It's not perfect, but it's a quick idea of what you need. Now, why is this important? It's very, very important. As you're looking at your batteries, especially if you get into lithium, you've got to look and see what that battery management system, you'll see it referred to as a BMS. What can that BMS supply you with? Sometimes the BMS will be 100 amps. Well, if you get into that, you're not going to run the big microwave. Now, that's not because of a failure of your inverter, regardless of what brand you use. You just don't have enough battery power to be able to operate. And what's going to happen? That inverter is going to go, oops, don't have enough, and it's going to shut off. So you're going to have to be concerned about that. And even if you put multiple batteries that are small and cheap in parallel, and let's say we got 100 watt, 200 watt, 300 watt, if your BMS will only supply 100 amps, it's still not going to work very, very well. You could potentially have problems. Now, not always, but potentially. So you want to make sure you get a BMS that can handle at least 200, or if it was really ideal and I was building my system, I would try to find one that will operate at least 250 amps. So the lithium battery that we'll be doing our testing with will have that extra capacity so we can kind of push it. So I don't have a microwave to put in, but I do have things like heat guns that'll go up to about 1650 watts. I think that'll be a good sign, so we'll go from there. All right, so let's go outside, enough of this, and do some testing. So what I'm going to do is I'm going to hook it up to a battery. We're going to do some load testing. I've got something called an oscilloscope. We want to look at that power sine wave and make sure it's clean. We don't want to see a bunch of jitters and rattles and clipping at the top. We don't want to see any of that. That'll drive electronics crazy, 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 crazy. So we don't want to have any of that, especially if you're hooking it up to something like a Starlink. You want to have very, very clean power. So we'll test that with an oscilloscope. We'll double test my calculation and see how far my math is off on doing a calculation on amperage draw. Again, I don't have 18 watts, but I think I can get 1800 watts. I think I can get close to it. And we'll just see what the battery power is going to the inverter. I think that's very, very important, and see how efficient this unit is when it's doing that power as well. All right, I've talked long enough. Let's head out to the workshop, put this on a battery, and see what this thing is going to do. I'm in the shop now. I have everything set up on the test bench that I want to be able to evaluate this 2000 watt BougeRV inverter. So just to kind of let you see what we have here, let me give you kind of a close-up of what we'll be dealing with today. I'm connected to a 300 amp battery now. The reason I'm using this large of a battery is because I'm going to be trying my best to max out as much of the inverter as possible. And this battery has a continuous 200 amp BMS in it, so that should be able to supply all the power that we need to the inverter. I have a clamp-on meter that you see here. I think this is really important to be able to look at this stage. I'm connected up to the side here of the inverter, and you see that I am drawing what 1.5 DC amps just in an idle state. So that's important to remember. The inverter is on. Now what I'm going to be doing for the testing today is I am going to be using the hardwire configuration. And the reason that I'm doing that is I want to try to get as many amps out of this as possible. So again, I'm going to be using two things. I'm going to be using the world famous heat gun test. This is a 1650 watt heat gun, so it's going to pull a lot of power, and I want to be able to make sure that I can get as much as I can. I mentioned earlier these are 120 volt AC connections, 120 volt. These are rated at 15 amps each. Now this is rated at 20 amps, still 120 volts but 20 amps, so we're doing that. I have a voltometer here that I'm looking at what the voltage is as we get this set up, and it's 120 volts. We'll just call it 120 volts. And I'm kind of confirming that with this panel. I've hooked the panel up. It's showing how much battery power I have, 13.7 volts. We'll confirm that. The battery itself shows 13.7 volts, so I'm glad to see that that is true. We also see that our output is 120 volts. It's bouncing back and forth, and we're seeing about the same thing here, 120 volts, kind of bouncing back and forth. There's no wattage. This also gives me a battery reading, so that's good as well, and it's showing that we do have a full battery. Now this is what's very, very important to me, and if you look here in the oscilloscope, you'll notice that sine wave, that's what that's called, I mentioned that earlier, is perfect. It's just as solid as a rock. There's no caps across the top. There's no jitters in the waves as they go back and forth. Good, solid sine wave. So we want to be able to see that here in the power. Now that could all potentially change once we put power on. Let's go ahead and start our testing. I've unplugged the voltmeter. We'll just monitor the power from the front panel here, and I'll leave the oscilloscope on. The infamous heat gun test. This should be 650 watts. It's going to be really noisy, so let's go ahead and get that turned on. It's really hot. We can see what we're pulling here. It is reading right at, am I going to get 16 up to 1620. So there we go, 1636, 1630, so about 1640, between 1630 and 1640, somewhere thereabout. This is what I wanted to see. The sine wave looks great. There's no capping on it. It's running fantastic. Remember my wattage, the efficiency is a little bit better than I had hoped for. So we're running 152 amps out of the battery, which tells me this is running a little bit more efficient than what I expected. Remember that rule of thumb was 1650 divided by 10. That should be 165 watts in my back of the napkin. But the inverter is a little bit more efficient than that. So we're running at 152. That's awesome. That's really, really good. Now you can see we've also got a dip in the battery. I'll kind of show you that. It was running a little over 13 volts, and you can see the sag on the BMS, but it's no problem whatsoever. I guess my point here is if you were going to use this with a large microwave, this should handle it well. I can probably try to get a little bit more amperage out of this, but I don't know what I can use at this stage that wouldn't overload it. We're within 2,000 watts. We're within 350 watts of the power, so it looks good. Well, let's get an inductive load on this. Let's get something big, loud, and noisy, some kind of a tool, and see how that's going to behave. This is going to be my last test I think we'll be able to push this to its limits with this. I don't know what's going to give out first, is the battery BMS or this unit. We'll see. I'm not going to run it a long time because I'm really going to push it over 2,000 watts. But the first thing that I want to do is run a power tool. Now this is my Porter cable air compressor. Golly, this thing gets used a lot. One of the things I like about it, 150 pounds, not sponsored, 150 pounds per square inch. So I use this to fill my tires on my camper when I need to. I have to take them up to 110 pounds. It's a lot. So still the same setup I've got. Again, we'll look at the voltometer. We'll look at, see what's coming out of the battery. I do want to see what this sine wave is doing once we start getting an inductive load on it. It's going to be loud. Now, adding to it, I'm going to take this Conair hair dryer. I'm not going to be able to put it on its highest setting. I think it's about 1,800 watts. But we will take it over take this over 2,000 watts. No need to let it go for hours and hours. But we'll just see if it can handle this for just a little while. The biggest issue, can I run a power tool? It's going to be noisy, so bear with me. Here we go. Voltometer's looking great. Voltage is right at 117, 118, perfectly within spec. I want to check the sine wave. Excellent. No clipping at the top. The lines are very straight. Very good power coming out. And then we're looking at the amperage coming out of the battery, just slightly over 100 amps to service this. So we're doing actually pretty good at this stage. For right at 1,100 watts. Now we're going to go ahead and turn on the hair dryer, add a little bit of wattage to it. You're seeing this jump up 1,600 watts. On the low setting, we're looking at 158, 159 amps coming out of the battery, and the sine wave, still, the inverter's doing a great job. And we're seeing we're up to 1726 now, 19. I'm going to go ahead and move the power up a little bit on this hair dryer. We're over 2,000 watts, 2,100 watts. We've definitely exceeded the capacity of this, and this is what's really impressing me, is that even exceeding this, the sine wave is good. 212 amps coming out of the battery. A 200 amp BMS, holding up great. We probably need to go ahead and turn the dryer off. Well, I think we've exceeded this. Look at this, 21. It's right at 2,100 watts, so no need to continue to push it. Voltage still extraordinarily stable. I'm really pleased with this inverter. It's doing a great job. Voltage was very stable. I'm very pleased with that. We looked at the oscilloscope. That was the key issue. That waveform was just as crisp and sharp. No flattened points on it. It didn't get weird or jaggedy. It didn't have any waves in it. It looked fantastic. Now I'm talking about waves within the straight line, not in the sine wave itself. It looked fantastic. Very pleased with it. And I did get it close to taking the battery past its limit. It's a 200 amp BMS, and I think I was doing a little over 200 amps out of it. So again, I was stressing about everything I've got to be able to stress it. All right, so let's recap this, and I'll give you some additional information. I think I pushed that 2,000 watt BougeRV inverter just about as far as I think you can go and prove that it's going to do what its specifications say what it's supposed to do. What do I look for in an inverter? If I get a specific wattage, I want to make sure that on the AC output I get exactly what it's rated at, and we saw that. It actually went a fraction over to 2,000 watts. Again, I would never push one that far. If you're going to size one, I typically like to size a little bit under the exact wattage. So, you know, if it's 1,000 watts that I'm looking at, I'm going to run 800 to 900 on it. If it's 2,000, I'm going to run 1,800 to 1,900 on it, something like that. Again, give myself just a little bit of headroom. That's just a good engineering practice. 3,000 watts, I'm going to run, you know, 2,900 to 2,950. Again, that's just a good engineering practice to always undersize or oversize the device you're going to work with. So regardless of what you're using. So again, we're looking at a unit that's $289. And I think it performed well. Good configuration, very nice clear display that gives you what you need to be able to see on it. A very good value. You know, I pushed it, it'll run an inductive motor. And the other thing that I look for is to make sure that that sine wave, it's a pure sine wave, it's nice, it's sharp, it's crisp. no square tops on it, no jagged lines in the straight line. Perfect. It's perfect. So really pleased with that. But I'd like to thank BougeRV for sending that to us. I'll give you a link in today's description if you're looking for a good value-based 2000 watt inverter. This is going to work very, very well. And I'll also put some additional information as far as charts, specifications, and links at ilovervlife.com and the blog that I'll be releasing today. Now, one other point about this inverter that I want to share with you. I have a project later on for our daughter and her husband, Julie and Josh, that I am going to be doing a small solar upgrade. I want to be able to show what that is can be done. They need a little bit of solar. They have no solar on their camper. They don't want a ton of solar. They don't want solar panels hanging off of it. So we're going to go with a very minor install. So I've got a BougeRV flexible panel that I'm going to be putting on top. I'm going to be doing the wiring. I've got the BougeRV 2000 watt inverter that you saw. I'm also going to be using one of these inverter, or one of these transfer switch boxes, 15 amp, that we're going to be doing this. This is going to be for powering their refrigerator. Again, that is not a BougeRV product. And then I'm going to be using a lithium battery, a 100 amp hour lithium battery. And what they want to be able to use this for is their propane refrigerator. They want to be able to put it on electric and let it cool when they have it parked for a period of time. They don't want to leave the propane running. They take it out during the winter to a hunting cabin and a hunting area, and they leave it out there, so they want to leave it on electric during that period of time and not leave the propane on. And they want to use it for traveling as well. So if they're going from point A to point B, they want to run it on electric and not on propane until they can get to wherever they're going, if they're boondocking, or plug it back into campground power and then have the transfer switch from the battery inverter over to camping power. So that project will probably be on later this year. I don't have an exact firm date. The hunting season is coming up in Georgia, and I'm not going to be able to go out to the hunting property and do it. But that opportunity will be coming up soon. And I think it'll be interesting to see what a minor install will be doing. So again, the next couple of videos to show what we can do from not only using it in our RV travel, but what you can use for disaster recovery. Do you have a battery that you could use? These lithium batteries, 100s and 200s, are getting incredibly low cost. And if you're using them in a home disaster recovery environment, you can save some money. You don't have to get the low temperature disconnect or the heaters. Very economical. You can do that. You can get you a 2000 watt inverter like I showed you. You can get very low cost solar chargers for good quality ones, like a Victron, for $68 that will run this and run a couple hundred watts of solar panels. You can start off with a 100 watt solar panel. 100 watt solar panels are under $100 now. It's just crazy what you could do. You could set you up a small disaster recovery thing, you know, keep your refrigerator or freezer running for a period of time, or keep your phones charged up, or, you know, any of those types of things, oxygen machines running, etc., etc., etc. So very inexpensive. So I'm going to be doing a couple of videos on these types of alternatives. I have another one that'll be scheduled in a week that will not be an inverter. It's going to be something a little bit different, so be able to stay tuned to that. Set up something that you can enjoy your travel and use your AC devices, or if you want to be able to have something for disaster recovery, I think you'll find these videos helpful. Thanks for watching. I hope you found this very interesting. Give me a thumbs up. If you've never subscribed, I would appreciate it. Would like to see you come back in the future and hit that alarm bell. And I do this for one reason. You got it. It's because I love RV life. See you in the campground soon.